going to give you the first section. Okay, as the syllabus have says, the quiz 1 should have covered chapter 1 to chapter 6. Okay, so look at chapter 1 to chapter 6 is basically covering topics like, okay, what is scientific investigation, what is broad problem area, what is literature review, etc., etc. So I will be giving you this one quiz. Okay, I'll be giving you this one quiz that consists of a scenario, and what you need to do is to just answer all these questions. And these questions are solely based on your syllabus, your topic. So I have given you this scenario, something like the first question might ask you to develop a problem statement. So develop a problem statement is basically telling me, answering the question, what is actually the problem of this particular scenario? What actually they want to do? Okay. Then the second question is basically develop research question and research objective. It's exactly like how you do your project paper, but this is just to answer question. So let's say if you have identified that there are 6 research questions in this scenario, you write down 6 research questions and 6 research objectives. And then question number 3 is to identify what are the variables. Do you have any independent variable, mediator, moderator, or dependent variable in this scenario? Okay, finally, you need to draw the framework, understanding this storyline, this scenario, and then try to visualize what is actually the framework looks like. And finally, develop a research hypothesis. So these 5 questions basically covers chapter 1 to 6 as per requirement of the syllabus, right? So this is what I'm going to give you. The first quiz, right? Answer this question. It's all short-lined. Don't ask me, doctor, so how many pages? Right? You look at the question, you already know that maybe the answer is, for each of the question, is not even a single page. Half a page. Just answer the question. Point form or statement form. Okay? So this is your first quiz, right? The duration is that I will perhaps start giving it you tonight, and then you have until end of the week, Saturday, to submit. Right? So I give you 1 week for this first quiz. And then after I have completed the topics on data analysis, okay, I will give you this. This question I can give you in advance. It's fine. Then you can try to answer. Okay. The second quiz, chapter 7 to 12, right? I will give you on next week, right? So there are second part of the story that talks about the methods. For example, what are the unit analysis? What are the sampling design? So basically, all these quizzes are to help you to recall and to refresh your memory about what you have learned, all this chapter. It's not to trouble you, right? So it is one way for me to assess how well actually you have understood all the topics. Okay, so there are case scenario 1 and case scenario 2 that I will be giving to you this week and next week. And all the submissions are the same, end of the week, right? Submit through online learning. Do it in Microsoft Word, submit it. So it will be something like this. Okay, so it will be something like this, like individual assignments. Then perhaps I will put down the question here. Then if you click inside, of course, I will attach the scenario here, and then you just submit to me, right? Written in Microsoft Word, or you have done in Microsoft Word, you want to submit as a PDF, also can. No issue. Right? So this is the part where I think I want to discuss about the next thing. Okay? On your 2 quizzes, which comprises of 40% and also your group exercises. Right? I will do these questions. I will put it up, right? Maybe this week or next week, because we are still talking about the chapters. I have not taught you everything. But these 2, I will give you 1 week and 1 week to do this. And this one, when I've created the submission platform, right? For those who have completed chapter 1, you can submit, right? The problem statement that you submit here is exactly the same like the problem statement you have in your research project report. Okay, so that's it. First part about your what we call it, the assignments and the way we are going to progress for the next 4 weeks, 3 weeks, right? So we still have 24 days. 24 hari saja, tapi tak adalah. Our meeting will be somewhat like maybe in around 6 or 8 times only. Okay. Okay. So I will proceed again with our discussion in the last class talking about statistical data analysis. Okay, and today we will do some quick recap on what is a univariate analysis that I have taught you, I have shared with you in the last class. And today I will specifically pay some of the attention towards what is a one-tail and two-tail analysis by giving you some examples. Okay, and hopefully that would take up much of the time. I believe that would take up much of the time. Then if time permits, then we will move on into again univariate analysis, but it is a univariate analysis that is more than two groups. Okay. Okay, so in the last class we discussed something about this. So group exercise is similar to your group project. Okay, it's up to you because like I've said, okay, for this part, if you have done it, okay, since you are doing a research project, for this part, you have done it, right? Once the platform is ready, you want to submit, you can submit. Okay, for this part of the study, okay, I have allowed you, the final date will be on the 24th. Right? Because this part I have not taught, I belum ajar lagi. I have not taught you about all the analysis. So maybe you can only do these assignments after you have understand everything. Okay, but for this one, once the platform is ready, you can submit. And these two will be within this week and next week. Okay. Right. Okay. Let's continue. Okay. So last class we discussed about this in brief. What is univariate statistical analysis? What is bivariate statistical analysis and multivariate data analysis? Right. If you are still not able to capture or you're not able to understand this topic, never mind, I will do a quick recap. Okay, so univariate statistical analysis is analysis that focuses on one variable. Okay, bivariate analysis is an analysis that focuses on more than one variable involving two. And if you have more than two, it is called multivariate statistical analysis. Now, the question is, some of you might have asked me some of the things. Okay, let's say okay, let's say some of you might have asked me, said, sir, you told us that univariate statistical analysis involving one variable. Okay, but sir, remember that in the last class, you taught us something about a variable, right? So at least in a very minimum, we have a few variable. Let's say this is the question that you asked me. Then I ask you, why do you say that you have so many variable? Then you started to tell me, sir, you see, we have gender as one variable, we have race as one variable, and we have satisfaction as one variable. So how can we do univariate statistical analysis? I don't understand. So these are the kind of question that you might have in the site that you want to ask me. Now I explain to you. Okay. In one way or another, when we come to data analysis, okay, the things that we consider as a variable is the items that exist in our research model. right? We need to think it in such a way saying that, okay, whatever that is inside a research model is called a variable. Then you ask me, so sir, is it gender and race is not a variable? I would say to you, yes, it's a variable, but it is not a variable in a model. So in order for you to understand that what is actually a univariate statistical analysis is that you need to consider things or items of variable that are in nominal or ordinal scale as a group, right? As a group. So in this case, when we talk about univariate statistical analysis, right, the only variable that we have, let's say, for example, in this example is satisfaction, right? So this is your variable. And inside this variable, you can divide the data of this variable into several groups. And the groups are either the groups according to gender or according to race. So this is what we call it as univariate. How about bivariate analysis then? Okay, a bivariate analysis will be more than two variables. So let's say, for example, if you have studied the relationship between satisfaction and loyalty. So now say you have another sets of data here. Okay. So you have two variables, also with two groups. With this, you can do a bivariate statistical analysis. Okay, and you have more than two, another variable, you go for the multivariate statistical analysis. And as what I have told in the last class is that when you have all the variables with the groups together, you can test for relational hypothesis, you can test for difference between group, and you can test for difference from some standard. And in the previous classes, I have shown you about testing the hypothesis between different groups, right? So to do a quick recap is that, okay, say for example, you have one variable called satisfaction, you have a set of data, and then when you divide the data according to group, either gender or race, you know that you can get values differently. For example, yes, you have 10 data for satisfaction, but that 10 data can be divided into 5 male and 5 female. And when you divide it according to group, you will get a mean of male and a mean of female, and then you can do comparison, whether they are the same or not the same. Okay, so that is the first part, the differences between group. Okay, and when you do this, that is called the t-test. Okay, a t-test is a test that allows you to test differences between two groups. Okay, so now the next question you have come in, sir, what if I want to divide the satisfaction according to race, which I have more than two groups? Okay, when you have an analysis of data that is more than two groups, it is called analysis of variance, or in one way or another, it is called the ANOVA, okay, analysis of variance, called the ANOVA test. Okay, and in order for you to understand what is an ANOVA test, you can go down to the video that I've given to you. So I have uploaded a video on t-test. Okay, there are independent sample t-test or one sample t-test. Okay, so t-test is for two groups. Okay, but if let's say you have Malay, Indian, Chinese, you can watch this video on ANOVA, analysis of variance. Okay, so this is the test that we are going to conduct. Okay, if today we have some time, I'm going to show you ANOVA. Okay, if you don't have time, then it will go to the Thursday class. Okay, so that is the differences between group. And also in what we have last class is that I also demonstrate to you that you can actually test a hypothesis about differences from some standard, which means that, okay, in this kind of case, okay, you have 10 data, definitely if you calculate the mean or the average, you can get one average. But before even you calculate it, you can speculate or you can anticipate a figure. Say that based on your gut feeling, you feel that the mean score for this is somewhere around 4.6. So you postulate a value, say that, okay, I want to confirm if my mean that I speculate is 4.6 is correct or not correct. You can do that. This is a test of what of the number. Okay, so in a layman term, it is something like this. Okay, today we still don't know how many cases of COVID that Malaysia have as of now. So you speculate based on the results of yesterday and the day after. We got 9,000 the day before, then we got 7,000 today, yesterday. So maybe on average, you I say, okay, maybe today's case is 7,200, say for example. So the hypothesis test about difference from some center is like this. So you speculate that it is 7,200 for today, and then you waited for 3 p.m. or 3:30, you look at the actual result. And if the actual result that comes out also is somewhere around 7,200, then you say, okay, your hypothesis is supported. But let's say today it comes up, the numbers is 8,000 or 9,000, and then your hypothesis is not supported. Okay, that is what we mean by the hypothesis about difference from a standard. Okay, the differences between the one that you speculate and the one that is actual. And finally, okay, we can proceed to discuss about the relational hypothesis. The relational hypothesis is a bivariate data analysis that examines relationship between two variables. So you need to have at least one independent variable and one dependent variable in order for you to do this analysis. Okay, so for example, in this case, with satisfaction and loyalty, you can hypothesize that the level of satisfaction influences the level of loyalty, and then you can do relational hypothesis to see if I increase 1% of satisfaction, can the loyalty also be increased by 1%? Okay, so these are the three types of analysis that you can do. Okay, and then I also share with you what is the process of testing the hypothesis. Now, today, what I would more prefer to discuss with you is on some statistical value. Okay, some statistical value. Okay, especially I would like to discuss on what is actually a one-tail univariate data analysis and a two-tail univariate data analysis. Okay, now, okay. So just now I speculated that the number of COVID cases is 7,200. The result just come in that today the numbers of cases is 6,824. So with this, I can try to conclude if my hypothesis is supported or not supported by using a t-test. Okay, so it seems like the case is dropping, which is a good indication. We hope that this will continue to go down further, right? But sadly, the case in Kedah is still remain very high, 400 over cases. Hopefully, the situation will get better. Now, okay, I would like to share with you what is a one-tail and two-tail test. Okay, before I even start, can I get a quick responses? Okay, have you learned this before in your statistic class? Pernah belajar tak one tail analysis and two tail analysis? tak pasti. Okay. Alright. Now, okay. Never mind. So today we will be focusing this because I think that this is the very basic things and it is the most important thing that you have to learn. Okay, you have to understand in order for me to be able to proceed and explain to you the rest of the test. So this class is considered one of the most important class that you need to make sure, because later on I will show you also some example by using the software. Okay, so one tail analysis. Okay, a one tail analysis is a type of analysis where you choose to decide the direction of a value. Okay, one tail test is a test where you choose to decide the direction of a value. What does it mean? Okay, a simple example is like this. Just now, I speculate that today's COVID cases will be 7,200. Okay, simple example, right? I speculated that today's COVID cases is 7,200. This kind of speculation or this hypothesis that I made is called point estimation. Okay, so if this is the hypothesis that I built, okay, contohnya ini hypothesis yang saya bina, okay, the today COVID cases is 7,200. What will be my alternative hypothesis? What will be the opposite statement of a statement that I do today? Can everyone try? Siapa-siapa boleh cuba? Cuba jawab, tolong respond, please. Okay. Sekiranya saya hypothesize that today COVID cases is 7,200. What will be the opposite statement of my statement? Apakah pernyataan alternatif kepada pernyataan saya tadi? Okay, again, I speculated that the case of today is 7,200. Okay, so Shuhada said the case for today is less than 7,200. Okay, that is one. Lagi? Okay. Right, today cases is decreasing. Okay. So this is what you do. Okay. Okay. So this is given by student. Any other answers? Ada lagi tak jawapan selain daripada yang Syuhada bagi dengan yang Syahidatu bagi? Can there be any other? Okay. I do a statistic form. Okay. Atira said no case for today. Amirul said case is decreasing. Okay. Cheng Yat said today case is not 7,200. Okay. So no case today, Atira, no case today kita letak di bawah lah, kurang daripada 7,200. Okay. So another answer by Cheng Yat. Okay. Now, there are three possible answers. Which one do you think is the best? Rasa-rasanya lah. Okay. Mana satu yang terbaik untuk menjadi alternatif kepada yang ni? Number one, number three, number one, number three. So let's say today, you want to play safe. Okay, you want to play safe, you want to play safe. Okay, you want to play safe. Kan? Okay, so I see the situation here is either one or number three. Okay, either one or number three. So kita buangkan yang nombor dua ni. So kita tutupkan. So now we have number one and number three. Let's say today kita nak buat tilik nujum, you rasa mana satu lagi selamat? Which one is much more safer? If you want to bet lah, number one and number three. Three, okay, tak apa. So banyak cakap tiga kan, tak apa. Kita tengok satu dulu. Let's say I want to hear from Shahidatul and Atira. Since you pick one, why do you think that one is safer than three? You can try to answer. Because it is sure that it will be less than 7,200. Okay, because cases is still higher, so it is impossible to get zero. Okay, but for number three, if it's not 7,200, it can be 8,000 or 9,000 like that. Yeah. So, okay, let's say now. Okay, let's say now. Mana dia? Okay. If I were to take your answer, and then I said 50%. Okay, so you said it is less than 7,200. Okay, then I take one. Okay, nampak ni. Okay, so the actual cases is 8,000. Maksudnya ini sudah salah lah, betul tak? Yes? Ini betul tak? Is this correct? Yes kan? Okay. Kalau macam ni, betul tak? Right? If the actual cases is 6,000, sekarang Atirah dengan apa ni yang Syahidatul punya jawapan betul tak? Betul kan? Okay. So, the question here, you compare these two scenario. One is larger, one is smaller. Which statement has a higher percentage to be correct? Okay, berbandingkan dengan dua jawapan ini, okay, mana satu mempunyai kebarangkalian yang lebih tinggi untuk dapat betul? Second one kan? Why? Because tak kira lah di mana janji dia bukan 7,200 saja you sudah betul, betul tak? As long as the number is not 7,200, you are correct. Yes or no? But in the first statement, you got a lower probability to get correct because the result will be other way around, right? Okay, so this is actually an example of what does it mean by a one-tail or two-tail analysis. Directional and non-directional hypothesis. Okay, if you do not speculate any statement that is saying either larger or smaller, this is called a two-tail analysis. Okay, this is called a two-tail analysis. Okay, it's called a two-tail analysis. Why? Because okay, given a distribution, you don't care where the direction is, right? So you are saying something like this, is it 7,200 or it is not 7,200? So as long as the value comes up 7,200, then your null hypothesis will fail to be rejected. But as long as any number comes up, but it is not 7,200, you are correct. Your hypothesis will be supported. This is a two-tier analysis. Maksudnya tak kira lah dia positif ke negatif, you are safe. A one-tail analysis, on the other hand, is called analysis whereby you select side, you pick side. Okay? In the sense that, okay, the hypothesis that you said you want to test is 7,200. Then suddenly the alternative is you are so confident that it might be larger. But when in actual it comes up lesser, then your hypothesis is not supported. This is called one-tail hypothesis. So in terms of testing numbers, you can say it like this. But when it comes to relational hypothesis, this is where one-tail and two-tail analysis plays a lot of difference. Okay, contohnya, your null hypothesis lalunya you cakap there is no relationship between A and B. Then intuitively you will say that the alternative hypothesis will be there is a relationship between A and B. This is a two-tail analysis. Why? Because you just say that they have a positive relationship, but you don't know whether the relationship is positive or negative. So this is the two-tail hypothesis. Whereas compared to a one-tail hypothesis, the null hypothesis will remain the same. there is no relationship between A and B. But when it comes to an alternate hypothesis, based on what you have read in the literature, based on the article that you have read, right, you can now confidently say that I think the relationship and A and B is positive. That will be your alternative hypothesis. And if you run the test and it comes out that the actual relationship is negative, right, then what happened is that your hypothesis is not supported because you say it is positive, but when actually it comes out, it is negative. So there are always pro and cons of a one-tail and two-tail analysis. But what is most important here is that you need to learn and need to understand why is it important for us to learn about one-tail and two-tail analysis. Okay, so I give you one example. So we are done with this example. Okay. Okay. Let's say today I have these sets of data. Okay. I have these sets of data. So I look at only the variable called satisfaction. Okay, so this is the responses. Respondent number 1 give an answer of 5, 2 give answer of 5, 3 give 2, 4 give 6, and I speculate that the mean of these sets of data is 3. So I started off by saying the mean is 3. Then most of the time, the alternative hypothesis will be what? Not 3, right? Betul tak? It's either 3 or not 3 kan? But if you go for one-tail hypothesis, okay, if you go for one-tail hypothesis, you can speculate mana dia? Let me see. Betul tak? Okay. So in this case, I speculated that the mean is 3. The other possibility apart from the mean is 3 is either the mean will be larger than 3 or the mean will be lower than 3. Yes or no? Betul tak? This is my speculation. Okay, I have a set of data and I articulate or I speculate that the mean is 3. But if I go for one-tail test, right, I cannot say that the mean is not 3. I need to be specific. Okay, you want to pick a side. Now tell me, if it's not 3, should it be larger than 3 or should it be smaller than 3? So there is 2 possibility. Okay, that's why when you run the t-test analysis, okay, you can have this or you can have this. Right, you can have this or this. But if you go for a two-tail analysis, it will be rather straightforward. Okay, it's either 3 or not 3. So what happened here is that, okay, if you plot these results in the terms of graph, okay, this is what you think 3 is here. This is what you hypothesize. Okay, if you think it is 3, the mean larger than 3, that means to say it goes this side, larger than 3. Okay? If it's lesser than 3, okay. So now the question is, what is the actual mean? Right? And then you also learn that using a confidence 0.05, here is 95%. Here is also 95%. And 0.05. This is the 5%. Okay, this is also the 5%. Now, here we have everything goes here is a value of 3. Okay, but if you have learned Z distribution, we are much more interested to know this. Okay, so there are Z distribution table. There are two values that is very much important for us. Okay, why I say so? Okay, in statistics, you learn that anything less than 0.05, you reject the null hypothesis. But what I'm trying to say here is that for business student, we don't always rely on this value. What I'm actually telling you is that I want to teach you on how to read what we call it as the T statistics here. Because because the T statistics is a more accurate statistics than the P value, because of the effect of one tail and two tail analysis. So now, just now you saw that one tail, it can either be this side or this side. And the value here normally is 1.645. The T statistics. Okay. For two tail analysis, okay, the diagram looks like this. So you allows it for either here or either here. So here is 95%, but here is only 2.5% because another 2.5%. Okay, here 95. Here is 2.5. Here is 2.5. That's why you learn in your statistics class that the p-value need to be divided by 2. Okay, mesti you all pernah belajar. You have learned this beforehand that the p-value must be divided by 2 because you go for two tail. Even though in center it is the same as compared to a one tail. Here 95, and then the rest of the 5% is either on the one side or another. Okay. So for one tail, it is 1.645. For two tail, it is 1.96. This is something that you need to understand. Okay. Now, what is the problem with this? Okay. What is the problem with this? Okay. Today, I share with you all these things in the hope that you don't always rely on looking at the p-value. Why I say so? Okay. because of problems with software. Okay, problem with software. Now, let me give you an example. Okay, let's see. Okay, if you are doing a one-tail test, okay, you can speculate that whether the mean is equals to 3 or less than 3, and then your null hypothesis will be more. So this one you have understand. Okay. And for two-tail analysis, it looks like this. Okay, so one tail, it is either bigger or smaller, and then the two-tail analysis, it will be equals or not equals 3. Okay, so there are conditions that you need to follow. Okay, so let's say we go to jar movie. See, so I have this satisfaction data, and I wanted to speculate if my value is equals to 3. So I said I want to start off with the two-tail hypothesis. Okay, two-tail. So when I said two-tail, that means to say my mean that I want to test is either similar to 3 or not similar to 3. So I put a test value called 3 here. And then I selected the choices to test whether it is similar or not similar to 3. But I'm not testing larger or bigger. So now you see what happened. Okay, I put on satisfaction. So I got my results here. Okay, so my results here giving me a p-value of 0.171. Okay, and I tested that I want to test if my H alternative is not equals to 3, which suggests that my hypothesis is something like this. Okay, so two-tail test. Okay, I want to test if my mean is equal to 3 or not to 3. Then I got a p-value of 0.171. Okay, so I put my value 0.171 here, t-value 1.489. Okay, condition, right? I told you that in order for you to reject the null hypothesis, okay, your t-value must be more than 1.96. But now your t-value is 1.489. So it is smaller, and therefore you fail to reject the null hypothesis, which is similar to this p-value. Okay. What if now, so two-tail analysis is very straightforward. Okay. Even if I run in SPSS, okay, the same data, I run analyze, descriptive statistics, compare mean, one sample t-test, and then I said I want to test satisfaction. My test value is 3, and I click OK. I will got the same results. I will get the same result like what I get in what we call it in Jamovi. Okay, look at Jamovi result. Okay, the statistics, the t value is 1.489. The significance is 0.171. So no problem with either SPSS or Jamovi. But when it comes to a one-tailed test, okay, maksudnya a test that is something like this. I said that my mean is equals to 3, and then my alternative hypothesis can be either more than 3 or less than 3. Right? Either one. Okay. So the beauty of Jamovi is that I can select which one I want. Okay. I want a test value of 3. Then the alternative hypothesis, I want it to be larger than 3. Okay. So when I do then larger than 3, it gives me 1.49, 0.085. Okay. Okay. So I said this is equals to 3, and then here I put a test value of larger than 3. Then I got Jamovi. Okay, Jamovi, it gives me 1.49, 0.085. Okay. So this one, I put it on hold. Okay. Now, I speculate something like this. Mean equals to 3 or mean is larger than 3. So what now? My P is larger than 0.05. I fail to reject the H now, meaning to say that my mean is 3. Correct. Okay, but let's see in SPSS now. Analyze, compare mean, one sample t-test. SPSS does not allows me to select something like this. Okay, there's no larger or smaller, so I just can put again all 3. Then I click OK. Then I got this result: 1.489, 0.171. Okay, so the P is larger than 0.05. Reject the H now. Okay, but why is it that the same data, SPSS and Jamovi, give different value? Kenapa? Nampak tak? Why is it Jamovi give me 0.085 but SPSS give me 0.171? This is because it says here, right? All the analysis conducted by SPSS, they give you a two-tail punya result. Okay, nampak two-tail punya result. Okay, two-tail punya result. So what happens here is that if you use SPSS, what I'm trying to say here, if you use SPSS, okay, but your hypothesis is one-tail hypothesis, your p-value need to be divided by 2. Then you got 0.085. Okay, this is the problem with statistical software. So only recently software like Jamovi they improvise. You kalau you punya hypothesis one tail, you select one tail punya result, but in SPSS you cannot do that. So it puts a note here saying that the result is two tail. So if its result is two tail, your hypothesis is two tail, you use a two tail punya result is correct. But if your hypothesis is one tail, like this, you need to take the two-tail result divided by 2, and then you get 0.085, which is similar to the one that given to you by Jamovi. Okay, but luckily, in this case, if you do not learn this, if you don't learn this, you are still safe in the sense that ini pun more than 0.05, ini pun more than 0.05. So secara rambangnya kalau you tikam pun dua-dua reject mah. Betul tak? Two of them reject. But there are certain situations whereby if you do comparison, suddenly Jamovi gives you significant, but then SPSS give you not significant. For example, something like this. This is what I did earlier this morning with another group. Let's say, for example, in a one-tail test, okay, instead of speculating the mean is 3, I change the value to 2.5. Okay, so I change the value here to 2.5. Okay, I got 0.023 according to Jamovi. The statistics is 2.32. So 2.32, 0.023. Jawapan dia apa? P less than 0.05, right? Sorry, I don't use this example. Tak nak guna example ni. Kita guna mana ni? Okay, we use this example. Sorry. Ini just throw it. This one I also. Where is it? Okay. Okay, so two-tail test, dua-dua bagi you jawapan sama. Now, let's say I change the value from 3 asal 3 kan. Okay, look at this 3, this is larger than 0.05, this is also larger than 0.05. You are safe. Okay, because dua-dua bagi you result, fail to reject. So your mean is 3, you make a conclusion. But let's say today I revise the value into becoming 2.6. So this is Jamovi. It gives me a statistics of 0.03 and the t-value of 2.15. Okay. So I put in Jamovi, t-value 2.15, p-value 0.03. Okay. But now I go to SPSS, analyze, compare mean, one sample t-test, I said the value is 2.6. So I got this results. Okay, nampak is 0.06. So I do a table like this below here. Now, this is a screenshot from Jamovi. 2.15, 0.03. This is from SPSS. Same value, but the P value is 0.06. So we go back here. Okay, Jamovi give you 0.03. SPSS give you 0.06. And the condition that you know is that P less than 0.05, you reject the null hypothesis according to Jamovi. But SPSS, P larger than 0.05, failed to reject the null hypothesis SPSS. So the conclusion, I don't know, sir. What do you want to conclude? Kenapa boleh jadi macam ni? Nilai sama, tapi P value lain. Kenapa? Right? It is because I told you earlier that SPSS results are based on two-tail. So if you have a one-tail hypothesis, your p-value need to be divided by 2, then you got 0.03. Then now you can make conclusion saying that actually the p-value is significant. So this is an example that I demonstrate to you to show that there are issues with software that you need to be aware of. Okay, kalau untuk software macam Jamovi modern sikit, okay, dia pecahkan nilai dia estimation based on one tail and two tail hypothesis that you have. But in SPSS, everything is two tail. So you need to look at your hypothesis, whether it is bigger or smaller. If you go for two tail hypothesis like this, no problem. The result will be the same. But if you have this larger or equals to or smaller than or equals to for SPSS, you need to always remember that the value is divided by 2. Okay, so what if you tell me that, sir, very hard for me to learn, I don't know, I cannot understand. Okay, the simple takeaway that I can give you is this. Okay, don't look at the p value. The p value will always be misleading. Try to learn on reading t value, because the t value, regardless of what p value that you get, it will always be accurate. Okay, you guna one tail ke two tail ke, you dapat value ni, t value adalah sama, sedangkan you punya p value adalah lain. So for me to guide you through is that very simple. Instead of looking at p value, I want you to learn on reading the t statistics, the t value. And what is the rule of thumb? Okay, if you have a one tail analysis, your t statistics must be larger than 1.645, you reject the null hypothesis. Okay, one tail analysis, the t statistics or the t value is larger than 1.645, you reject the null hypothesis. So in this case just now, your t value is 2.15, which is larger than 1.645. Therefore, we reject the null hypothesis. Okay. How about two-tail test? Okay, ini one tail punya. Two-tail test, okay. the t value, okay, the t value for two-tailed test must be larger than 1.96. So in the case that we look at it just now, the two-tailed test is 1.85. Okay, p-value 1.489 is smaller than 1.96. Therefore, we fail to reject the H now. Okay, so determining the cutoff value for one tail test, the t statistics must be 1.645. For two tail test, it must be 1.96. I give you an example here. Okay, don't look at SPSS anymore. We look at Jamovi. Okay, say for example, now we go for two tail test. Okay, the test value is 2.6. Okay, the test value is 2.6. The p value is 0.06. The t value is 2.15. So let's try. Okay, one hypothesis. Okay, okay. So you have kenapa dia jadi macam ni? Okay, you have this one. Okay, no, I don't want. I want this one. Come on. One tail, two tail. Okay, so your mean is 2.6. Okay, let's try this. 0.6 here is not 2.6. So you have a t value of 2.15 and a p value of 0.06. Interesting. P is less than t value 2.15, which is larger than 1.96. Therefore, we reject the null hypothesis. But why give me a p-value of 0.06 when in actual the mean is 3.9? Interesting. Okay. Two tail 95, 0.025, 1.96 now. Okay, never mind. For this one, I will check and then I will try to get back to you. Okay, because there seems to be some contradictory statement. Supposedly, it should have been larger than 1.96, but I have a t statistics of 2.15. This is borderline. If this is correct, one tail is correct. It's not. Okay. Right. And anyhow, you can still rely on, for two-tail analysis, you can still rely on this. I would say, no, this is not correct. Two-tail, fail to reject. But here, reject. Okay, never mind. For this one, for one sample test for two-tail, I will check again and then I will get back to you. Okay, but for this one, it is definitely correct. Okay, it is definitely correct. But this one, I will have to check why is it gives me two contradictory results. I will check and then I'll get back to you. But for this one-tail analysis, it is always correct. Okay, so one point of the time, if you don't want to see the p-statistics, you can always refer to t-value. This is what I'm trying to say. And once you have understand this t-statistics, t-value, okay, it will be easy for us to continue to discuss on all these kinds of statistics in the subsequent classes. So now it's already 3:50, and I think I spent almost an hour trying to explain to you what is actually one-tail and two-tail analysis. So I believe we will start talking about the test of differences for more than two groups, the ANOVA analysis of variance on Thursday. Okay, so I don't know, maybe today's class is a bit heavy for you, but I really tried to make you understand about the one-tail and two-tail analysis. I hope you get something out of it. And in case you're still confused, never mind. We have the video recording, and in any cases, you can come and ask me. All right, so I think that's all for today's class. Okay, I don't want to disturb you further. Okay, anyone have not scanned their attendance? Please let me know. Don't call me.
Me, sir.
Amir.
Yes, Amir.